Picture this: two identical small buildings, same size, same weight, sitting on the exact same soft ground. One sits on a narrow foundation, it sinks, and slowly starts to tilt. The other sits on a wide foundation, it doesn't move at all. Same weight. So why does only one of them sink? That question is basically the whole idea behind why some buildings stand up and others don't. Hi, if this is your first time here, I'm Carlos. I spent 7 years as a geotechnical engineer, which means I spent a lot of time figuring out whether the ground under a building can actually hold it up. This channel is where I explain that stuff in plain English, starting with the basics. Let's start with the mud and the board example. Imagine you're standing on soft muddy ground, like your backyard or construction site, after a heavy rain. Your friend standing right next to you weighs exactly the same as you, but they are standing on top of a wooden board. You sink into the mud, and your friend doesn't. Here's the thing: it's not about how heavy you are, it's about how much ground is actually holding you up. Your feet push all the weight down into one small spot, so the mud underneath can't handle it, and it gives away. Your friend's board spreads that exact same weight across a much bigger area, so no single spot has to hold very much. The ground underneath is totally fine. That's it. That's the whole idea. Pressure isn't just about weight, it's weight divided by how much area is spreading that weight out. Same weight, bigger area, less pressure in any one spot. In plain engineering terms, bearing pressure is the amount of force a structure applies to the ground spread across the area of its foundation, usually measured in pounds per square foot. That's the exact number engineers calculate before anyone ever pours concrete. Imagine this: you're carrying a big backpack full of books. Now imagine standing on one leg. Your foot pushes really hard into the ground, and you might sink into soft mud. Now imagine standing on both feet. The backpack weighs the same, but your weight is spread over twice as much ground, so you don't sink as much. That's what you're seeing here. From looking at this image, load is simply how heavy something is. In this instance, a building. The footing is the building's giant shoes. Its job is to spread the building's weight over the ground. Bearing pressure. How hard is the building pushing on the ground? Now, let's swap the people for buildings. A building is heavy, like a person standing in mud. The foundation, the concrete part of the ground, is like that wooden board. If the foundation is too small for how heavy the building is, the ground underneath gets too much pressure in one spot, the same way your feet sank into the ground. Make the foundation wider, and that same building weight spreads out and the ground can hold it just fine. That's bearing pressure. It's just how much weight is pushing down on how much area, and whether the ground underneath can actually take it. Here's why engineers actually care about this. Every building rests on an assumption. Whoever designed the foundation is trusting that the ground underneath can handle the pressure the building is going to put on it. Get that assumption wrong, the foundation is too small, or the soil underneath is weaker than expected, and you get exactly the kind of problem this channel talks about: buildings that tilt, buildings that crack, buildings that sink unevenly on one side more than the other. Remember that tilting building from the very first video on this channel? Bearing pressure is the actual starting point for understanding why that happens. Every single failure this channel is going to cover traces back to the same basic idea: weight, area, and whether the ground underneath was ever actually strong enough to take it. So how do engineers actually figure out bearing pressure before a building ever goes up? They test the ground directly. They drill into it, they push tools into it, they measure exactly how much it pushes back. That's the job: finding out before anyone builds anything whether the ground can handle the weight it's about to be asked to carry. We'll get into exactly how that testing works in a future video, but for now, just remember, it always comes back to weight divided by area. Here's a real one, and we'll get back to it on episode 3. In 1913, an entire grain elevator in Canada tipped over 27 degrees intact like a falling domino because the ground underneath couldn't handle the pressure it was being asked to carry. It's still standing today, and it's one of the most famous case studies in this entire field. We'll break down exactly what happened and exactly why in episode 3. Next video, we're covering the next piece of this puzzle, the difference between bearing pressure and bearing capacity, and the full story of that grain elevator I mentioned earlier. If you're enjoying this video, hit that like button and subscribe. See you in the next one.